right, hopefully everybody can hear my voice. This video has sound, so hopefully everybody can hear it. Otherwise, they're watching me point at this sign and hopefully getting their sound going. This is a lesson on section 12.2.1, chapter 12, section 2, part 1, out of the chapter 12 Geometry Study Guide. So we'll start off with some preliminary vocabulary. A prism is a three-dimensional object where the top and bottom of the shape, or I should say three-dimensional object, are congruent polygons. So, for example, this shape right here, you can see the top is a triangle and then the bottom is a triangle that's the same shape. That's a prism. Or, let's see. This cube could be a prism, as long as the top and the bottom are congruent. And you've got these lines that connect each corner, each correlated corner directly. That's a prism. Lateral means side. You have lateral muscles on the sides of your torso by your rib cage. So lateral faces are the side walls of a 3D object or prism. Lateral edges are obviously the edges on the sides. The surface area is how much surface it would take to cover the whole object, top, bottom, and all the sides surface. Lateral area, this is interesting. Lateral area is just the area of the side faces only, or the up and down portion of the shape. A net is basically if you take an object that's a three-dimensional, let's say polyhedron like this, and you cut around the edges and then you lay it down flat. It might look like this, for example. If you took a long, like a shoebox basically, where you had kind of 4 flat rectangles in the middle and these are the 2 ends of the shoebox. If you cut it and then laid it down flat, it would look like that. So this is what a soup can looks like when you cut it into 3 objects. This is the top of the soup can, that's the bottom of the soup can, and this is the wraparound part in the middle of the soup can. So if you could technically cut this out, put it back together into a 3-dimensional object that would look like a cylinder. It would look like that. So when you deconstruct a 3-dimensional object into just its surfaces in such a way that you can lay it out flat, that's called a net. And these are 3 examples of nets. There you go. So if they can be put on a flat surface all together, that's the net to the 3-dimensional object. A right prism is a prism. Remember that a prism has the top and the bottom polygons that are congruent. A right prism is a prism where the lateral edges and faces are perpendicular to the top and the bottom. So the lateral surfaces are perpendicular to the top and bottom. Technically the bottom is called the base. And if you flip it upside down, then the top will be the base, because it's the new bottom. If it's not a right prism, then it's oblique prism. It's where the lateral surfaces, the lateral I can't write today, my goodness, surfaces are not perpendicular to the top and bottom. So it's basically a shape that looks like it's like hanging off to one side. It's like tipping, like the Leaning Tower of Pisa. That's an oblique prism. I don't know if there's any pictures of that here. Nope, I don't see any in this section. Okay. So, the main formula that you'll need to know is the one that calculates surface area. Now, technically, there are other ways of doing this. All you really have to do is find the area of the top or the bottom, which is a triangle, right? And if it's a right prism, the top and the bottom should be the same area, so you'd add that area plus that area. Then you could find the area of the front, which is just a rectangle. Find the area of the side, over here, that's a rectangle, and the area of this side, which is a rectangle. And then just add up the surfaces of all five, top, bottom, side, side, side. All five of those shapes will give you the total surface area if you add up their individual areas. Now, if you don't like that kind of individual approach, what you can do is just use this formula. The formula says that for any right prism, meaning that you have a three-dimensional shape where the top and the bottom are the same, that's a prism. And it's a right prism when the walls are 90 degrees to the top and the bottom. The formula says that if you multiply the base area times 2, big B means base area. And add that to the perimeter, that's P, times H, which is the height of the entire object. See that right there? That would be the surface area. So if you have, I'm trying to figure out which one of these I was using in my examples. I think the first one, so I'm going to go with this one. If you have a shape and you have these two congruent sides, those are the bases. And then all the walls in between them, those are your lateral surfaces. Basically, you have to make sure that your shape, this is how I think about it, is sitting on one of its bases. And then whatever distance between the two bases, that's your height. So down here, I don't see this shape as sitting on one of its bases because the bases are the two congruent shapes that are opposite from one another. So technically this is sitting on its side, this object, to me, not straight up and down. So what I like to think of it as is a shape that's tipped over. So if I redrew this so that this was down flat on the surface, if it was standing up straight, then this would be my height, right? So it's really important to figure that out because 6 is not your height. 6 is just one of the edges of your bases. It's just that this shape was knocked over. So I'm just trying to think if I can redraw this. like so. I have this other side back here. Yeah, I didn't do the best job of this, but anyway, you've got this other side back here that's kind of hidden. There we go. Okay, good enough. So this is the object that'll have drawn in a way that I think best helps me interpret these words, because this is the height. The height is actually 8, not 6. And this is my base. These little triangle ends here, those are my bases. So you can see that they've taken one of these bases, these equilateral triangles, and they've redrawn it right here. That's your base, this whole object. And the reason why they redrew that is that we're going to try to find the area of that, because you can see that's part of the formula. Big B means find the area of the base. So to find the surface area, let's find that big B first. So this base, since it's an equilateral triangle, I can find the area by taking let's see, if I drop down, I've got notes here that don't make sense to me. I've got a formula that I haven't shown you before, so it doesn't make sense to show you that. Let me see what I have in my other notes. 1 second here. Okay. This is a better way to explain it. Okay. So basically what I'm going to do is, just as we did in the previous section, this is a regular polygon, right? As long as all 3 sides are the same, we can use the formula area equals, for all regular polygons, 1/2 times apothem times perimeter, right? So we practiced that in 11.6 a lot. So I'm going to say 1/2 times whatever the apothem is times the perimeter. Now the perimeter is 6 plus 6 plus 6, which is 18, right? That's pretty easy to calculate the distance all the way around. There's your perimeter, 18. Now the apothem, I showed you how to find that by dropping it down like so, and then taking basically the right triangle relationship that we know to be true. This is 6 and this is 3. And we want to find this distance here, that's A. So this length right here is one of the legs on a right triangle. And okay, so I can say that leg squared plus leg squared equals hypotenuse squared. And oh, you know what? I didn't do it this way. I'm sorry. I used the other formula for a triangle because it was shorter than this. Okay, let me back up 1 second. I'm not going to use the formula for regular polygons like I used in 11.6. On this one, I'm actually just going to use the generic formula for the area of a triangle, which is 1/2 base times height. That's what I want to do. Now we certainly could do it the other way, it's just going to take more time and work. So I'm just going to show you how I would solve this in the fastest, most efficient way. So that's why I'm changing gears right now. If you don't mind, I'm sorry. Let's do it this way. Okay, the base on my triangle down here is 6. The height is what I'm trying to calculate. That's what I want. That would be the fastest way to find the area of this triangle. That is the base. So leg squared would be, again, this is my right triangle I'm talking about, 3 squared plus leg squared, that's my height that I don't know, equals hypotenuse squared, that's 6. So I would have 9 plus h squared equals 36. And subtracting 9 on both sides, I'd have h squared equals 27. And then taking the square root of both sides, I'm going to say that that is approximately, if I grab my calculator here, uh, 5.196 for the height. So the area of this base, because it's a triangle, I'm going to write it up here. So I multiply 5.196 times half of 6, which is 3. So you can go 0.5 times 6 times 5.196 if you want to. I get about 15.59. Okay, now that is the area of the base. Now in the formula, this base is represented by a big B. So the surface area here equals 2 times the base. Now why do you suppose we multiply that by 2? Because we have two surfaces that are our bases. Basically this one here and then the other one up here. Those are the bases. Now the perimeter of the base, we found that already. That would be 6 plus 6 plus 6, or 18. And then the height of the object was given to us. Once we set it right side up, we could see the height was 8. Now there's a lot of bases and heights and things that are confusing. First of all, big B means the surface area of the object, that's surface that this is sitting on, this three-dimensional object. Little b here was the base on the triangle of the two-dimensional object. So try to distinguish between little b and big B. The other thing that might cause some confusion is height. This h right here was the height of my triangle in this two-dimensional object. But this h here in this formula represents the height of the three-dimensional object, which is a different one. Unfortunately, they're both written as a lowercase h, which can be really confusing. So try to keep all of your letters straight. Try to, figure out just step by step what you're doing, and then what are you going to do with that number once you find it. Slow and easy wins this race. If you try to rush through these problems, you're going to probably be in some big trouble. But anyway, twice the area of the base here. The area of this base was about 15.59. Plus the perimeter of the base, which was 6 plus 6 plus 6, or 18. Times the height of this whole object. Again, this object had fallen over because the bases were opposite each other sideways. They should be, one of these bases should be sitting on the surface, should be sitting on the bottom. So that's why I redrew the object where I tipped it correctly, and then I knew that this was the height. So now we can finally multiply. If we multiply these two together and then those two together and then add them all up, let's see what we get here. So this times 2 is about, let's see, 15.59 times 2 is 31.18, and 18 times 8 is 144. So when I add those two together, 1.18, I get about 175.18 square inches for the surface area covering this entire object. So this surface, that surface, and then the 3 wall faces, all those 5 surfaces together give me a total surface area of 175.18 square inches. Now this one might be a little bit easier to understand because it's just a basic rectangular prism that has right angles everywhere. So using my formula, the surface area to cover this entire three-dimensional object equals 2 times the area of the base plus the perimeter of the base times the height of the whole object. Isn't quite as challenging as example 1. The base, the thing that it's sitting on down here, is a rectangle, right? It says that the height of this object is 5, the length is 11, and the width is 4. So the base down here is a rectangle with a length of 4 and or a width of 4 and a length of 11. So it would be just length times width for the area of this base, 4 times 11, or 11 times 4. Now the perimeter of the base, this rectangle has 4 sides, 4 and 4 and 11 and 11. So the perimeter would be adding those up, 11 plus 4 plus 11 plus 4. And then the height is the height of the entire object. The way that it's sat right now is fine. That's 5. The reason why the height here is fine is that the top and the bottom are congruent shapes, and all these lines connecting them are right angles. So we can still use this formula as long as it's a right prism, which it is. And the top and the bottom are the same, are congruent to one another. Okay, so length times width here would be 4 times 11. And when you add up 11 plus 11 plus 8, or 4 plus 4, you get 30. So 2 times 4 is 8, 8 times 11 is 88, 30 times 5 is 150, and when we add all that up, almost off the screen, we get 238 square feet. Now these are those things called nets that I was talking about. When you take a shape and a three-dimensional object, and you cut it so that you can lay it down flat, that's what you get. You get these things called nets. So if I want to find the surface area, what I could do is just find the area of each one of these two-dimensional figures and then add them all up. So for example, this is a square. The area of this square is just side times side. And since all the sides are marked as equal to each other, they're all 3s. So the area here is just 9 square centimeters, which would be the same thing here. These are all congruent to these, and we know these are 3, so these are 3s. So again, this area of this square right here would be 3 times 3, which is 9. And then the rectangles in the middle, they are 12 units long, and then the height of them is, or the width of them is 3. So each one of these rectangles in the middle, if you go length times width for them, that would be 12 times 3, or 36. So remember, on any three-dimensional object, you can do this too. You don't have to memorize the formula. You can just kind of pick apart each of these surfaces, calculate the area of them individually, and then add them all up at the end. So I have 4 of these rectangles, so I have 36 plus 36 plus 36 plus 36, and then 2 of the squares, 9 and 9, and then that would give me the surface area of the entire object, which is 162 square centimeters. Here with the cylinder, I could calculate the surface area of this circle, because the area of the circle is pi r squared. So it looks like the diameter is 10, so the radius here would be 5. So if I take five and I square it, so the area of a circle would be pi times radius squared. So if I don't forget to square first, 5 squared is 25. So I would get the area of this circle to be about 78.54 square units. And I'm assuming, since this is a it looks like it would be shapes on the top and the bottom of this can of soup that would be the same. I'm assuming the area here is the same as the area here. So that would be the area for that and the area for that circle. And then how do we figure out this rectangle? Well, we would need length times width, right? The area of the rectangle. So we have the width, which is 6. But how long is this thing? Well, basically the length would be the same as one distance around the outside of the circle, because if you took this to be kind of like the wrapper on a soup can, it would need to be as long as the outside edge of the top or the bottom of the can in order to be able to wrap around. Now I'm assuming that it's going to match this edge to that edge exactly and not kind of overlap at all. So if I could find the circumference of the circle, that would be the same as the distance from here to here. So the circumference of the circle would be pi times diameter. So the diameter is 10. So if I take pi times 10, I get 31.416 feet long. Now obviously this is not a soup can. This would be more maybe like a big industrial sized drum of sorts, or maybe a large garbage can somewhere. Anyway, 31 feet long, 6 feet tall. Those are our widths and lengths here. This circumference of the circle, as I mentioned, is the same as the length of this side. So that would be about 31.416. So if I multiply that by 6, I get the area of the rectangle to be about let's see, 6. Oh, sorry, I already wrote it. Okay. 188.496. Okay, I'm just wondering why this isn't coming up as the same answer that I have on my sheet. Let's see. Perimeter. Yeah, that does look right. So that's for surface area. Rectangle. Okay, so then if I add these two up, I would have the surface area. I'd have 2 of these plus 1 of that, right? So circle plus rectangle would be 78.54 plus 78.54 plus 188.496 gives me a grand total of about 345.58 square units, or square feet, I should say. Okay. Now I'm not going to do all these on this page because there's a lot of work involved in some of these. I will show you some of them that may be a little different. So I think what I'm going to do is I'm just going to show you my work on my work page. So for example, we've done one like this. The base is a rectangle. Length times width would give you the area of the base, which is 40. So 2 times 40 is 80. The perimeter of the base is 10 plus 10 plus 4 plus 4, which is 28. That's the perimeter of the base. And the height of the object is 6, so that's 6. 28 times 6 is 168. That one we did already on a previous page. On this one I calculated the areas of each one of these triangles, and then the area of the square, and the area of this rectangle, and the area of that rectangle, and then kind of added them all up. For number 2 up here at the top. There we go, now you can see it. I was just looking at this work right here. Obviously this answer is not the same as this answer. And I think I must have made some mistake over here, but I couldn't see it in the work that I showed because I really kind of shorted myself in my work. So this one seems like a more reasonable answer than the other one. So I'm going to go with this one, not that one. So just ignore this answer up here. Okay. For this one, what I did is I used that formula for, I wanted to find the base. So you remember the bases are the objects that are, the two walls that are across from each other and congruent. So that means that this object is sitting on a base. This object is not sitting on a base because these would be the two surfaces that are congruent to one another. So these are actually the bases, not the side that it's sitting on. So this one I would consider to be a shape that I call knocked over. Somebody pushed it over. So the base is actually in the front and the height is on the side. So you'll see here when I found the height of the object, it's actually 12 due to the fact that it's kind of sitting on its side. The perimeter of the base is actually the perimeter of this triangle. Remember the base, if it's knocked over, would be in the front, right? So I use the Pythagorean theorem up here to calculate the length of the hypotenuse. And then I used that and I added it to the 5 and the 8 to give me the perimeter all the way around the outside of the base. So 5 plus 8 plus the hypotenuse gives me the perimeter of the base, which was 22.43. That's your big P right there in the formula. Let's see, the area of the base, I just did the traditional triangle formula. I did 1/2 base times height. So since this was the base on my triangle, and that could be used as a height on my triangle, it is the distance from the highest point straight down to the base, so that's a height. I just used the basic, like I said, formula for triangle, 1/2 base times height, to find big B is the area of the base. So calculating all those numbers together gave me the 309.21 square feet for the whole surface of this object. Now there's another way to do this. You don't have to use the formula, right? You could calculate the area of this rectangle and the side rectangle there and the rectangle on the bottom, and then calculate the area of the triangle here, which is the same as the area back there, and then add up those 5 areas, front triangle, back triangle, and the 3 side rectangles, and you should get the same answer. And that way you don't have to memorize this formula. Okay, now number 6 is a prism that has a pentagon base and congruent pentagon top. So here I use the formula 1/2 apothem times perimeter. Since I knew that each one of the sides of this pentagon was 5 centimeters long, this is 5, this is 5, this is 5, this is 5, and this is 5. So big P, remember, is the perimeter of the base, and since the base is the same as the top, it would be 5 plus 5 plus 5 plus 5 plus 5, or 5 times 5, 25. That would be here. Oops, I'm sorry, here. And I used it also in this formula to find the area of the base because I used the formula we learned in 11.6, which said that any regular polygon, the area is 1/2 times apothem times perimeter. So I'm actually using the perimeter once in this big formula and then once here in the formula within a formula, so to speak. But if I use this formula, I have to find the apothem. So what I did is I kind of grabbed this triangle right here and I wrote it up here. Half of this side would be 2.5, the whole thing is 5. The radius is 4. And then to find the apothem, I just use the Pythagorean theorem. So substituting that into my formula, 1/2 apothem times perimeter, I can find the area of the base, my pentagon. And according to this, I have to multiply it by 2. And then the only other number that I needed was the h at the end. The h is the height of the three-dimensional object, which is 6. Now the last three examples are pretty advanced because they ask you for an unknown within the formula. You have to kind of set it all up and then solve it out. So I think I'm just going to show you those answers. So you can see I've used this formula every time. I've set up a surface area equals 1/2 area of the base plus perimeter times height. But I'm using the numbers that they gave me in each case to solve for x. So I substituted all the numbers and letters that I had been given, and then I just kind of kept simplifying and then solved for x in the end.